Hello everyone, welcome back to my YouTube channel. So now I'm going to solve question number 2 of weekly contest 487. Final element after subarray deletions. Very interesting problem and very good problem actually. You are given an integer array nums. Two players Alice and Bob play a game in turns, with Alice playing first. In each turn, the current player chooses any subarray nums from L to R such that the length of that subarray r minus l plus 1, it should be less than m is nothing but m is the current length of the array. The selected subarray is removed and the remaining elements are concatenated to form the new array. The game continues until only one element remains. Alice aims to maximize the final element, while Bob aims to minimize it. Assuming both play optimally, return the value of the final remaining element. A subarray is a contiguous, non-empty sequence of elements within an array. So Alice aims to maximize the final element and Bob aims to minimize it. And these are the constraints. Nums.length is from 1 to 10 to the power 5 and nums of I values from 1 to 10 to the power 5. So here, if you see this example number 1, 152, 152. So Alice is going to play first. She wants to keep the maximum element. So what she will do? She will just remove it, let's say. So if she removes it, so now we are going to get this 5,2. Now Bob's turn comes up, right? And he wants to minimize it, so he is going to delete this. So in the end we are left out with this 2. So 2 is the output. So one valid optimal strategy is Alice removes 1, array becomes 5,2. Bob removes 5, array becomes 2. Thus the answer is 2. Now see this example number 2. Alice comes first and she is going to keep the maximum value, so she is going to delete this 3, and in the end we are just going to left out with this 7. So Bob can't play now because only we have to play this game continuously until only one element left, so we have to return this. All right, so here if I take any big example, let's say 2 8 11 5 7, something like this. So in this case also, if you see, alice alice wants this element to be in array, so let's say she deletes this. So now I'm left with 11 5 7. Now Bob turns comes up. Bob wants this element to be removed. So and Bob wants to, let's say, keep it. So let's say Bob remove it. Now I'm left out with this 5,7. Now Alice turns comes up. So among this, what Alice is going to choose? Alice is going to choose this 7 only. So she is going to delete it. So in this case also my output is 7. Clear this part? Clear this part? Right. Now same thing what I will do here. Same thing I will do here. 2 8 11, and here let's say I am writing 10. Just I change this 10. Okay, now in this case also Alice wants to keep it, so she is going to delete it. Now I'm left out with 11 10 and 7. Now Bob's turns comes up. So Bob is also very clever, right? So Bob in last case, now he wants to just keep it now, so he's going to delete it. Again my result is 7. See here, Bob also playing optimally, so he knows that he wants to keep the minimum element, so he's going to delete 10 also this time. Here this position, here he didn't read this element, but here he did. Right, again my answer is 7. Okay, now can I try anything else? Let's say here I'm writing 2 uh 13 11 13, and let's say here I'm writing 5. So now alice alice is going to keep the max element, so let's say this one, so she deletes this. Now I'm left with 13 11 13 5. Now Bob comes, and what Bob is going to do, he's going to delete all the elements. He wants to keep minimum, right? So again I'm left out with this 5. In all these cases, here if you see, my answer is this. In this case my answer is this. In this case my answer is this. Here in this case also my answer is this. Here in this case also my answer is this. Right, somehow all are showing the last element. Okay, no worries. Let me give this example now. 14 7 5. So now in this case Alice is going to come first, and she is going to delete all this stuff. Now my answer is this, right? Here in all these cases, if you notice, my answer always lies with the first and second element, whatever the, but within the first and last element. So I have to just compare the first and last element Whatever the max, just return that as the output. That's it. 14 and 5, bigger is 14, return 14. 3 and 7, bigger is 7, return 7. 1, 5, 2, in this case, we have to just compare these two. Now, bigger is 2, return 2. Okay, so here also, bigger is 7, return 7. Here in this case, 2 and 7, bigger is 7, return 7. So, Alice, I can simply say one line. Alice never wants to trust Bob, so she will never let him play this game. So what she will do in the starting itself, if we have elements a, b, c, d, e, let's say, so she may keep this and read everything here, or she may keep this and read everything here. That's it. She will never give the turn to this Bob guy, right? Because Bob is also very clever. So here, see how easily he delete everything here to keep this. So he can also play such type of game like Alice. So Alice is never going to trust Bob. So that's it. So code this, see, its time complexity is just over 1. That's it. So nums.length, you are calculating first element, last element, return the max of them, and just return the answer. That's it. Very easy. That's it. So I hope that you guys are clear with question number 2 of weekly contest 487. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Next video. Thank you. Bye bye.